Hello guys, let's talk about the value types, which is also known as data types in this solidity. So value types are called value types because the variables of these types will always be passed by values. For example, they are always copied when they are used as a function arguments or in the assignments. So let's start with our basic contract and understand the value types one by one. As I have already explained, the pragma will be the first line here, which will also specify the compiler version which has to be used maximum. Then we will start with the contract, and then we will define the contract value. I'm just or the contract name. I'm just calling it a. The value you can call it anything. Let's call it double A, and then we have to define the constructor. To define the constructor, you have to type function and then this. So this will complete the small contract. Now we'll start typing the data types one by one. So first and the most common value type is the uint. Uint is mostly used for currency value or amount, as there is not there is no float or the double in that case. So it can also be used to store the Unix timestamp, as it stores very large number. So uint stores the data in 256 bits or 32 bytes. Due to being unsigned, it can store a very large number. So this is how you declare uint x. You can also initialize the uint during the declaration like this. So you can assign any value that actually matches with the range of the 32 bytes. So int is also the another type of integer like this. So the difference is that this integer type is actually a signed integer, which means that it will have a positive as well as the negative value. And the space needed by the integer variable is still the same to 256 bits. Since it is signed, it stores the smaller value, not the larger value like uint. So again, you can declare a variable to be int, or also you can assign the value to be like this. If you make an integer constant like this, int constant a 89, then this value of a cannot be changed of once it has been initialized. So by making the variable constant, you tell the compiler that it has to replace all the occurrence of a everywhere in the code, so that it can optimize the program variables. So also you can, while declaring the value or the integer, you can also specify the size. So by default the int is always 256. So when you say int 256, it is actually equal to int a. So technically this is actually equal to int a. Similarly for the uint also, you can also specify the size if you think that you need a smaller size. So you can actually use 128, or technically any multiple of 8 you can use to declare the integer type. So remember that this requirement of space has to be in the multiple of 8. Okay, so let's now check the typecasting. Let's declare it as a B. For this small typecasting, so you can actually typecast the variable using the value types. So for example, if you have variable like this int x, then and there is another variable b, then you can typecast the b to integer type and store it in x. This is very much possible. Also you can declare the boolean variable like this. So bool status, right? You can also specify the value boolean status is equal to true. Also you can make this boolean status as a constant. That's also possible. So you also need to note down that you can also declare a variable, which means that the value will be determining the type of the variable. For example, if you declare a var a and you first initialize a with, let's say, a boolean type value, then type of a will become a boolean, right? And then otherwise, if you, let's say, declare a variable b and store an integer variable b inside the b, then the type of the b will become integer. Right here the a will be a boolean. So var actually leaves the value type to be open until unless the first value has been assigned. So next data type, and the important data type, is address. So remember, the address is a special value type which stores the Ethereum address of 20 bytes, or it can be even, which is in bits. If you measure, it will be 160 bits of the. Remember, the address can be private or public, so you can also have the access type at address public owner. So this will become the owner. Variable name will be the owner, the address will be the type, and the public will be the access modifier. So bytes are also available in the Ethereum from size 1 to till 32. So like this, so you can declare byte a, this will become actually a bytes 1, or you can have bytes then 2 as a variable, or bytes, let's say 20, or whatever. So remember, this size of the bytes actually can go up to 32. So you can have bytes 32 as large num as a variable. So this is all possible. So now the dynamically sized bytes can also be declared like this: bytes m. So this will become a dynamically sized array, or you can say a spatial array, where the type is something similar to this, because we are actually not specifying the size of the bytes, so it can be unlimited bytes. So also we have the string here in the Ethereum, where the string is the just same as bytes, but the string does not allow length or the index access of as of today till this date. But this may allow in the future, depends on the Ethereum compiler designing. So this is how the string can be defined. You can type just string, then string whatever the value name, and then double quotes, and then value. So remember, the string has to be in the double quotes, not in the single quote. So now let's check out the arrays, how to define the array. For example, if you want someone to define the bytes, 32 bytes length of array, you can just put this length here, then it will become a static array. Let's say, right, then the size of the array will become 5 statically. It will not be changed automatically. But if you want to create a dynamic array, then you can create like this. Names 2. This will have the unlimited in size, unlimited size. So also that if you add the value in the array, it will return using the push method. It will return the size of the array automatically. For example, if you have something like this, uint new length is equal to, let's say, names, sorry, nicknames 2 dot push, then it will actually give you the new length of the array, so that you can perform the operations on the array, you using the for loop or do while loop, or whatever you want. So next is the mapping. So dictionary or the mapping can also be defined in the solidity, which may be of any type to any type. For example, this will define a mapping from string to a use unsigned integer. And you can create a variable name like this, public balance. So to access the particular key, so it will remember like this. It will be balance, then the key can be a string. As you can see here, the key has to be string and the value will be the integer. So let's say, and then let's say 56. So this is how you can initialize the particular balance using this data structure. So we also have the enumerator type. So enumerator can be defined using the enum variable. Let's say we are defining a state enumerator, which can be either created or logged, or let's say inactive. So now this enumerator type can be defined as a value type like this: state public state. This can be done. Now the state is also a variable. Small state is a variable. Now let's say if you want to define a value inside the state, then you like this dot created. So remember, now the state value is actually this created. This can also be converted into the integer by using the typecasting. So let's say if you want to have a variable state value is equal to state, so this value will be actually 0, because this state created is equal to 0, then this will be 1, then this will be 2. So this is how you can actually define the value. So you can also define the structure using the struct keyword. Let's say a person, then inside the person you can have height, age, address. So this is how you can define the structure, and then create the variable of this structure at any time. So this is how you can define the structure. Okay, so we completed almost everything. So this is how you actually define the variables in the Solidity for the Ethereum development. Thank you.